Okay, so now we have that legendary level for the project of like once you did get the water to the hospital, right, now distribute it throughout the building. And this is super strange, I think. Yeah, you'll see that there are issues with this. So each of these you had some range of flow rates, right? Right, you had minimums and maximums on each of these flow rates for each level. And then you also had, again, more lengths and more components throughout the levels. I think there were ball valves in here. The important part is this is an increase in elevation, and this is an increase in elevation. And then you have this system right here. So for multi-pipe systems, I think the best way to go about those types of problems is you have to just go straight to the circuit, because you don't want to get lost in, maybe think about too much like a piping system, and then you can see what can and cannot happen. So this will be my head. Pumps really are batteries in this situation. And then what happens? Well, let's say I go along right here. I don't know if I had any resistances there. So then here you have some resistance, flow resistance to get to there, flow resistance to get to here, flow resistance to get to there, right? There's an elevation resistance there, etc. there. So then transforming that to a circuit, right? Let's say there's none there. I don't know if I did have any there, but if it is, I would just lump it into that resistance. Don't worry if you don't understand that. Nope, it was just that one. Okay. So this type of distribution problem is where you can transform into this concept right here, right? Where this had L's, this had an LD material and a K, same with here. This also has a K in there and an L in there. So this all contribute to this resistance to flow there, resistance to flow there, resistance to flow there, and there. So I would hope that if you looked at this and if you would remember the idea that there's one law you could actually apply to each there's one law to apply here to maybe give a first check of something isn't making sense yet. I didn't get really any questions on this, by the way, so that's why I put this out there. Okay, so you have this battery over here and then all these head losses based here. So, something's up, because the one thing I do know say this is A. Right? That's all right. One thing I do know is only that. So that's why there almost is a variation in the flow rates around there. So if you actually know what the flow rate is here and the flow rate is, if you know these actual flow rates, you can just calculate these and see if it's right or not. So this idea of maximum flow rate is an issue, right? You go ahead and try to just turn this, to just ramp that up to the max, ramp that up to the max, and ramp that up to the max. If you did do that, well, then you could actually calculate what this head loss is here, here, and here. And I bet you wouldn't see that they're all equal, which would violate, which would violate conservation of energy. So there's a range there. Right, and the way is if we want this range to happen in the building, and you realize it can't happen, maybe it does, right, and you realize it can't happen, there is that follow-up question that is, well, Do other floors need some other head loss to them to get specifically these flow rates? Because I didn't even tell you what this HA is. HP. So I'm interested to see how people go about solving this because it's very unclear. We just know that we have a reservoir of water. We got up to the building. We imagine we need to buy a pump here to distribute it throughout all the levels of the floor. And then I just know that I have some flow rate requirements for each floor. And the question being, can they all run at the same time? What about them at minimum value? And then that should draw attention to like, well, how does this achieve then? I mean, in fact, right, I just told, right, so one thing you do is you can just ramp them all up to the minimum value. These wouldn't be the same, then this would not be the same. So maybe you could figure out what value of velocity, what value of the flow rate does equate all of these things. So I want to stop there because I want you guys to go through reasoning out those issues that come about with this. I know there's not a lot of time left, but again, like if you just have this diagram set up for this type of problem, it wouldn't take. I don't think it would take. I mean, I don't think it would take that long concerning what things you know and don't know. Again, you have information about flow rates, right? Right in that type of problem, you have information about flow rates and pipe geometry, and then not the head geometry. So if you go back to the multiple pipe flow problems, it's actually doable. So I might, yeah, okay, yeah. I didn't get any emails or messages about like confusion based on this distribution problem. Maybe everyone knew this, but I figured I wouldn't off the bat guess that. So I just wanted to draw this picture for you of how to solve that problem, and to hope you put maybe people correct things or see if they're doing the right thing. Because if I find that your head losses aren't the same when I draw this out, that's bad. You should know that, right? It's kind of that's definitely fundamental on the head losses for something like that. Engineers should know the more fundamental things in the details, and then kind of dig more into the details, I believe, because that's how anyone would check your work, is to check that the head loss across them is the same. Right? Think about more achieving this than the minor calculations, I would say, for that second part. And I hope to get a slew of questions maybe based on that, but I just wanted to put that out there.